All right. Thank you, everybody, for coming to the session. How many of you use requests? Yes.
Oh, wow.
Kenneth, that must really make you happy.
Thank you very much.
I have to say, Kenneth is one of my Python heroes, and finally, the reason I wanted to chair this session is because I'll get to meet him in person.
Oh, thank you.
He's a Python hero for me because he writes APIs that are designed for humans, unlike most of the scientific computing community. All right? So, and as we all know, and I'm part of the scientific computing community, so I'm allowed to say that. He's the creator of requests, and as we saw, a lot of people use requests. It's a very popular package. And he's here to talk about Pipenv, which is another tool designed for humans. So with that, Ken, please take it away.
Hi, everybody. Welcome to PyCon Day 2, I think it is. Is everyone having a good time so far? All right. I want to say a special thanks to Ernest W. Durbin for organizing the event. I think he's done a great job here in Cleveland, and I'm looking forward to next year as well. So this is the future of Python dependency management. So hello, my name is Kenneth Reitz. If you'd like, you can follow me on Twitter at Kenneth Reitz. Every follow is appreciated, as always. I work for DigitalOcean. This is a new thing for me. I was working for Heroku, but I just switched jobs about 5 days ago. I wanted to make sure I was representing my new company at PyCon, so I signed the paperwork and went straight here. So I'm still going through onboarding and everything, so I can't speak officially on anything yet, but I'm very excited to join the team, and I think it's the world's most approachable infrastructure as a service. So if you have any questions about DigitalOcean, or if you think there's any opportunities for us to collaborate, or anything you want to know, you can come ask me about that later. I'm also a board member of the Python Software Foundation. I'll be giving a lightning talk about that later today. The Python Software Foundation is an organization that exists to protect the intellectual property of Python, as well as run this event effectively. That's where most of the revenue for the organization comes from, is from PyCon. And that's one of the reasons PyCon exists. And it's a wonderful organization. And anyone here, everyone in the room, I assume, is invested in Python because you're at PyCon. So I encourage everyone who isn't already a member to become a member. It's free. It's also donations are always welcome. But you can go and sign up and become a member. And then if you want, you can become a voting or an active member, so you can help vote and help steer the future of the language with board decisions and stuff like that. So if you know who I am, it's probably from the requests library, which is HTTP for humans. It looks like this. And it allows you to make HTTP requests very easily on the internet with Python. Before this library existed, it was very difficult to do this because there was urlib2 and other tools that were not as friendly, I'll say. And this has been very popular, and I'm very thankful for the community for being so embracive of this project. It's very humbling. Some other projects are on GitHub. If you maybe recognize me from some of these, OSX GCC installer is responsible for it's called Xcode install Xcode select -- install. It lets you install GCC on your Mac without installing the 5-6 gigabyte Xcode. That's because of my project, OSX GCC installer. And I have a bunch of other stuff, Maya, Records, Tablib, etc., and the import this podcast. But anyway, that's enough about me. I'm here to talk about packaging, the Python packaging. So who here uses Python packaging? So who here doesn't use Python packaging? Let's do that instead. One person, 2 people. So Python packaging affects almost every single person who uses Python. And it has a bit of an interesting history because people have come to Python at different periods of time. I've been using Python since about 2007. And so which is not, I know people who've been doing it for much, much longer. So that's not a respectable tenure of Python. But compared to some people, it is. So I have some glimpses into the history of packaging. I'd like to share my perspective on the history. So there's some things that might be a little unclear about the current state of things and why things are the way they are and how much progress we've actually made. So in the past, Like when I started writing Python, if you wanted to install something, what you would do is you would download this like tarball effectively from the internet, and then you would unzip it, and then you would run setup.py install into your site packages directory, and it would get installed. And this is the de facto way to install Python packages. Some people would actually just unzip it and drag it into their site packages folder. And that was kind of the way that you would manage your Python dependencies. And that was the way it used to be. There were some problems with this approach, obviously. The cheese shop I may refer to is is a nickname of the Python package index, and which is pypi.org now. And it was merely an index of packages and not a sole package host. So right now, if you go to register a package on pypi.org, you have to upload files with that. Like, you can't say the files live on this other server that I'm hosting somewhere else. So before, you could have registered packages and say, oh, they're at this website and this website and this website. It was just an index. So that was problem A. So the packages were often hosted elsewhere. If it was running on the server, which served the entire Python community, was running on a single box in Sweden, which was very problematic. It was just this one little box running in Sweden. But its usage was a fraction of what it is today, so that wasn't really that big of a problem. It worked, and everyone was kind of happy. More obvious problems is that this installation system was a very manual process and was not good for automation. You had globally installed packages, which were impossible to have two versions of the same library installed, which we still have today, obviously. You can't have, if you install, I'm not using historically relevant things, but if you were to install Flask 1.0, you can't install Flask 09 in the same Python installation, for example. So if you only have a global Python installation, you couldn't work on two projects that have conflicting dependencies. So people, and it's just a poor user experience overall. So the next iteration of this is known as easy install. That was something that was very popular for a long time. It made things a lot easier. You would just type easy install space the name of the package, and it would go and grab it from the cheese shop and install it into your system, which is fantastic, right? It's much better. This is a much better experience for installation, but the packages were installed from the cheese shop, and it's much easier to automate. There were some downsides to this. There was no easy uninstall, for example, so you could just install things, you couldn't uninstall things. So that is kind of a slight step backwards. And I'll give you a painting of what today's world looks like. So from about 2010 onward, this tool named pip became the de facto replacement for easy install for managing packages. And virtualenv became common practice. And people started passing around these things called requirements.txt files. Virtualenv, what it is it creates an isolated Python home for each package to be installed in, one for every project. You can create a virtualenv, you can install things into it, and then in another project, you create another virtualenv, and you can install different versions of dependencies, and they're isolated from each other, and it's wonderful. And as time has evolved, it doesn't include the global packages by default anymore, so you're very isolated Python environments, you get very reproducible builds. It's a wonderful tool. It's a very powerful concept, which allows for extreme flexibility, and it's kind of unique in the Python community. Is a tool that, for example, does not exist in the Ruby community, and one of the reasons for that is because you can have multiple versions of gems in the Ruby community installed at the same time on the same system. In Ruby, if they had a Flask, you could install Flask 1.0 and 09 into the same global installation at the same time. So they don't need virtualenv. And then the other tool we have is pip. Pip resolves, downloads, installs, and uninstalls Python packages from the package indexes or arbitrary URLs. It utilizes requirements.txt files, and it manipulates virtual environments. I assume everyone that raised their hand that said that they use Python packaging uses pip and is familiar with it. So I won't go into too deep detail there. So this practice of using pip in virtualenv continues today. This is a practice that began in about 2010, and it's what we use today. Now, if you look at other communities, there's some interesting patterns that you've seen evolved over the years. In Node.js, they have yarn and npm. In PHP, they have composer. In Rust, there's cargo. In Ruby, there's bundler. All of these things share this very similar mechanism known as a lock file. But if you look at Python, we use pip and virtualenv, which first off is two things, not one thing, like all the other languages, other than Node. But they have two one things. And there's no lock file. Now, it could be argued that the requirements.txt is a lock file, but we'll get into that in a moment. But in Python, there's no lock file. So that's a problem. There's a problem with virtualenv in the first place, which is that it's difficult to understand abstraction layer. It's a headache for newcomers, which increases the barrier to entry to the language. If you're very familiar with Unix concepts, it makes a lot of sense. But if you're not familiar with Unix concepts, it's a little bit foreign, and it really does kind of hamper your ability to understand what's going on. It's a very manual process, easy to automate, but unnatural to use manually. And there are tools like virtualenv, which exist that makes this a much easier process to use on a day-to-day basis, which is great. Requirements.txt also has its problems. The very common pattern is you do pip freeze and you pipe that into requirements.txt, which gives you a flattened version of all your dependencies, kind of like, this is a reproducible version list of all my dependencies and my transient dependencies into my, for my project that I'm working on. But there's this impedance mismatch between what a requirements file is, because there's two different ways to declare a requirements file. There's what you want installed and what you need installed. We'll get into that in a moment. There are tools that exist today that make this easier, like pip tools, which I want to give a nice shout out to. But ideally, a requirements.txt file is a completely pre-flattened dependency tree, which is required in order to establish deterministic builds. That's what it, in the ideal case, should be. So this is one way of doing a requirements.txt. This is the ideal case for it. If you look at it, so this is a Flask project. Flask has transient dependencies. If you require Flask, it has dependencies itself, like WorkZig, It's Dangerous, Jinja 2, for example, and they all have different versions. So if you're to pip install Flask and then run pip freeze to a requirements.txt file, this is what the output looks like. This is great because it's deterministic if you were to pip install this from a fresh virtual environment. And it's all inclusive of transitive dependencies. But it's a little difficult to know what's going on. If you were to look at this in your source code repository on GitHub, or your coworker was to send this to you, which dependency is it that you actually want? It's unclear. Like, do you want It's Dangerous? Is that what your team needs? Or does your team need Flask? Which one are you actually depending on? And that's the problem. So some teams solve this by just doing this, because this works. You can just do Flask, and everything else will get installed. But unfortunately, it'll result in a non-deterministic build. It's much more human readable and understandable, and it functions properly, but it's non-deterministic, which can cause build failures. If any of those transitive dependencies update, you'll get a different version of those dependencies, and your application could break. It could be security vulnerabilities. There's many implications of that. So this is this impedance mismatch between what you want and what you need that is problematic with the requirements.txt format. So this effectively, this requirements format that we have is both a lock file and not a lock file, depending on how you use it. So let's just go with the assumption that Python has no lock file right now. The solution is to give it a lock file. So we already went over this, the two types of dependencies, what you want and what you need. So one solution to this is to have two different requirements files, one with what you want and one with what you need. So you have one called requirements to freeze, and you put in what you need in there, like Flask. And then you have one called requirements.txt, which is the result of pip freeze. And this is a good solution to this problem, that you can use standardized tools like pip. All you need is pip to do this, and this gives you the best of both worlds. And there's also a tool called pip tools, which does a very similar thing that is built all around this concept, basically, which I highly recommend using if you are not going to use what I recommend later. So this is a great pattern, and I think that this is a good solution for people that use pip in their build infrastructure to give you the best of both worlds. But it's not a real solution. The real solution is this new standard that's evolving, and it's coming out of the PyPA called the pip file. The pip file is a new standard replacing requirements.txt in the future. It's written in TOML, so it's easy to write and read manually, and it features 2 groups. So in other tools that you use in those other languages, you can often have groups of dependencies. You'll also see people have requirements-dev, requirements-test, requirements-production, requirements-Heroku. These are a way of finagling groups into pip. So with the composer community, however, has gotten away with having just 2 groups, and it's been a very successful project in doing so. So pip file has room in the spec to support more groups, but we are currently, the implementation has 2 groups, packages and dev packages, which should encapsulate everything that you ever need. Anything that's not going into production goes into dev packages. Everything that is going into production goes into packages. And that should encapsulate every single use case you could ever possibly have, ideally. And pip file is something that is going to go into pip once Donald Stuff gets around to it, basically, which is wonderful. It was his idea, and I went through and I made a prototype of the spec in Python with some help from some contributors. And there's a project called pipfile you can use to parse these files and manipulate them. And it exists, and it's going to go into pip one day. So that's the future of this, is that pip file will replace requirements.txt. So here's what a pip file looks like. It's TOML, so at the top you see source, and that specifies which package index you're using. And it has some parameters like verify SSL equals true, which should always be the case. And you can give the index a name like PyPI. And there's those 2 groups, like I mentioned, packages and dev packages. So in this instance, there's Flask, and I'm assigning it to version star, which means grab the latest version, and dev packages, or really what it means is any version, which defaults to the latest version. And then dev packages has PyTest, so that's a good example of what you would put in those 2 different groups, right? You'd put like your test runner in dev, and then you put like Flask in its default group. And then this thing can be processed and result in something called a pipfile.lock. And this is really where the magic of pipfile comes into play. Pipfile.lock is JSON, so it's very easily machine parsable, which is great, and statically analyzable. It contains all transitive dependencies pinned with all acceptable hashes for each release, and it has, again, 2 groups, default and develop. So this is probably a little hard to see. It's a really big file. I have it truncated. But those you can see in yellow here, there's click, there's Flask, and there's the version numbers. And then it includes all the hashes, the 256 hashes of all the different wheels and source distributions of those valid dependencies, which is great. So we have what we need in here and what we want over here. These are 2 separate things. And this generates this. So that's the ideal. The problems with pip file are that it's not yet integrated into pip, which will likely take quite a long time due to resource constraints. But you can use it today with Pipenv, which is the new project that I am working on that I want to encourage everybody to check out. And that's what this talk is about. So the Pipenv sales pitch is that it's the officially recommended tool from python.org for managing your Python dependencies. It lets you use pipfile and pipfile.lock today without waiting for pip to implement it. It automates away virtualenv completely from your workflow. It does use virtualenv, but you don't have to interface with it directly. It just does it for you. It ensures deterministic builds, including hash check verification upon installation, and it gives you other great tools like pipenv graph, which I will demo for you shortly. Some great quotes. Yannis Lydell, who's the former pip maintainer, said that Pipenv is the porcelain I always wanted to build for pip. It fits my brain and mostly replaces virtualenv wrapper and manual pip calls for me. Use it. And Justin Miles Holmes, a good friend of mine, said, Pipenv is finally an abstraction layer meant to engage the mind instead of merely the file system, which I quite enjoy. All right, so it's time for a demo as well as Q&A. So if you have any questions while I'm doing the demo, please line up, and I will do my best to answer them. I want this to be an interactive demo, so please come and ask any questions that you have as I'm going through. And hopefully my SSH connection to my server will go well. Let's see here. Is that big enough for everybody to see? Yes? Excellent. OK, so I just created a new directory called demo, and there's no files in this directory at all. So what I'm going to do, I already installed pipenv. I'm going to do pipenv install requests. And what it'll do is it will create a virtual environment for me automatically and create a pip file for me automatically. And then it'll install requests, and it'll create the pipfile.lock, and it'll relock the file. So now I look, there's two files, pipfile and pipfile.lock. If I look at pipfile, you'll see requests is in there, and it automatically specifies, we support version specifiers, so you can constrain your application to certain Python version specifiers. So this one requires Python 3.6. If I want to install a dev package, I could do like pipenv install pytest --dev, and it will install pytest into the dev package directory, and it will relock automatically. And as you note, I don't have to edit this pip file by hand. It's doing it for me. That's an idea I got from Composer. So pytest is there, request is there, and this all works. So I could remove the virtual environment with pipenv --rm, which deletes the virtualenv completely. And I just do pipenv install, and it'll rebuild it from scratch. And it's using Python 3.6.2, unfortunately. It should be 3.6.5. I can specify the version of Python. Let's try that. There we go, 3.6.5. There we go, I got that. And so pipenv install, and it'll install the dependencies. And it actually runs pip concurrently. So if you have 45 dependencies, it will install them concurrently. So you don't have to wait sequentially for each one to install one at a time. So it's much faster than using pip as well.
Can you support multiple sources concurrently? So
multiple sources.
So that you could have a organizational internal sort of PyPy running a dev.py?
Oh, yes, it does. Yeah, you can specify. If you go into the documentation, there is a way for you to specify multiple sources and then also assign a specific package to come from a specific source in the TOML file. Yes.
Sorry, if you have a question, please go to the mics.
Sorry. You mentioned concurrent installation. What about packages that?
What about what?
Packages that install differently based on what's installed before, like Tornado. If you have Cython, it will optimize. If you don't have Cython, it won't optimize. So
if you don't have Cython?
Yeah, Cython is not really a dependency for Tornado. If you don't have it, it's okay.
Yes. Yeah. So we don't have ordering built in. Oh, you can turn off sequential. You can add sequential flag to it, and it will run them sequentially, instead of doing them at the same time for that use case.
Okay.
And so the next thing you do after you've done this is you run pipenv shell, and this will give a sub shell to you with that. So if I run Python, I got 3.6.5, and I can import requests, and request works just like you would expect. And then you do exit, and it exits out of that shell into my parent shell instead of deactivate. But if you want, you can do pipenv --venv, and this will show you the path to the virtual env that it created. And it's just a normal virtual environment. So I could do source this /bin/activate, and it's just like a normal virtual env, so there's no surprises there. And I'll get to the next question in a moment. I'll install something that has a bit more dependencies like Maya. Oops, pipenv install Maya. We got some nice features in here like pipenv graph. Which will give you a graph of your dependency tree. So here's my top level dependencies. Here's requests. Here's its dependencies. Here's what's required. Here's what's installed. It's quite nice. As well, I could do pipenv install Django. Can someone give me the name of an insecure version of Django? Very insecure? 142? All right, so I'm installing Django equals 142. And the Wi-Fi isn't the fastest, I apologize. And I have a security vulnerability scanner built in that's offered by PyUp. I have an account with them, and it's embedded in, the API key's embedded inside. So you can do pipenv check. And it checked the 508 requirements, which were those constraints. It said Python 3.6, so it checked, and that was all good. But here are some known vulnerabilities in my dependencies. So that's a nice feature that we have as well. So I installed that invalid version of Django, and here are the vulnerabilities for that version of Django. So you can get some nice checking of your code and stuff like that, build that into your CI. Pipenv graph is really useful. In addition to install, of course, you can do uninstall. You can do pipenv uninstall requests, not that you should ever do that. And it'll remove it from the file, from the pip file, and relock automatically. I could also, for example, edit the pip file, right? I'm just going to change it, right? So I just added some new lines. And then I'm going to do pipenv install -- deploy. So this is what you would use in production if you were going to go deploy to like in a Docker image or in production. You would never want to ship you never want your lock file to be out of sync with your pip file. So this will work fine, apparently. Hang on. Maybe we cache I think we do a hash on the values, not on the content. So I have to add like a comment or something. That wasn't a real change. Yeah, so your pip file was out of date. It expected this hash, and this hash is found. So it'll abort the deploy automatically if you pushed a new pip file and didn't lock. But of course, you don't need to use that in development. If you do, it knows that it's out of date, and it'll relock automatically for you. So next question.
Thank you for your work on requests and Pipenv. My question is, at early days of Pipenv, the virtual environment was created in the project and the default was changed to home directory.
Yes.
Could you tell us more about that decision?
Yes, so by default, if you do pipenv-venv, you'll notice that it's the virtualenv location is .local share virtualenvs. That's different. It's just slightly different based on your operating system. It's in a known good location for your operating system. It mimics the behavior of virtualenv wrapper effectively, which I determined was the best practice for the community. If you prefer not to do that, I could make dir.venv and then do pipenv install, and it will use the .venv directory for you automatically if there's one there. Or if you want, there's an environment variable you can set, which will always use .venv no matter what. So it's called pipenv venv in project. So that's a setting. Yeah.
So my question.
Yes.
My question's a follow-up to that. Is it possible to create a virtual environment in a directory that's not in the .local and not called .venv?
No.
Okay.
Not currently.
Okay, not currently is okay. Thanks.
Not with this. Well, actually, yes. So.
That's even better.
So I can make a virtual environment called test. Oops, what is it? Virtualenv? Sorry, I've been using pipenv for so long. So I'm making a virtualenv called test, which is using Python 2.7. I'm I'm going to source test bin. Sorry, this is taking a little long. Activate.fish. All right, so I activated my virtualenv, right? Now I run pipenv install, and it knows that it's running in the virtual environment, and it will install things into that virtual environment for you.
Perfect, thanks.
Yep. And if you want to switch versions of Python, I just messed everything up, so let me recover from this. So pipenv --3 will create an environment with Python 3 automatically. Oh, see, I'm in that, I had to deactivate. It gives you a nice friendly message. Pipenv found itself running within a virtual environment, so it will automatically use that environment. There's a setting to disable that, deactivate. So now that I'm out of my virtual environment, I can do pipenv --3, and it'll remove that environment that I had and recreate one with Python 3. And if I want to switch to 2, I just do pipenv --2, and it destroys it, creates it with Python 2. So very simple. And if you want, you can do --python, specify the path to any interpreter, and it will use that Python interpreter. It doesn't work with PyPy at the moment, but it works with every other Python interpreter. And you can also specify arbitrary versions of Python like 2.7.14. And if they're not installed on your system and you have PyEnv installed, it will compile it from source and make it available. So, next question.
Hi, I have a question regarding the speed of like installing new packages and stuff. It seems like it takes a long time compared to just regular pip, I'm assuming because it's calculating hashes or something. And I've done some Googling on the issue, and it seems like I'm not the only one. So have you heard of that issue so far? Do you have any inputs on that, or maybe ways that could be sped up? Because like installing new packages, I think it's calculating hashes.
Is it the installation that seems slow, or the locking?
I think maybe you're right. It might be the locking itself.
Yeah, the locking can be slow because it has to resolve a dependency graph. And if you have a large graph, it can be slow. But we've made massive improvements to that, and it's getting faster every day. So resolving a dependency graph, it turns out, is quite difficult.
Gotcha.
So it involves quite a few requests and stuff like that. And it has to download all those packages. So, yeah.
Okay, so in the interest of time, I'm going to have 3 more minutes of questions. So 3 more minutes of questions.
Speed
round. And I'd like to start first with the lady in the back there.
Hi. So I'm interested in using this, but I'm not necessarily going to get everyone in my company to start using it right away. Is there a way that I can convert between this log file and a requirements.txt so that people who are using either can use the library?
If you do pipenv lock-r, it will output a requirements.txt file.
Awesome. Thank you.
Yep.
Are we on? OK. Should we put the log file under source control?
Yes.
Thank you.
When you uninstall, is that recursive? Does it remove all the dependencies that were brought in because of that install?
Say it one more time.
When you uninstall, is that recursively uninstalling everything that was brought in for that dependency?
No, it'll uninstall only that package.
Okay.
There's a sync command which will automatically, that's a separate command which will sync your environment to the lock file.
OK, thanks.
Yeah.
Up front.
How does pipenv know which virtualenv corresponds to which application directory?
From the path of the directory. So if you were to move it, it would create a new virtual environment. Yeah.
Okay, behind.
Was there kind of a big difference in terms of when you're designing an API that's for Python versus an API that's like for consumption through shell and like is more interactive and not just something that you implement in your code?
Yeah, I think when you're designing something, if you look at the code base of pipenv, the Python side of it is not the most elegant code base I've ever worked with because it's trying to present the best user interface possible. Mm-hmm. So I think there's compromises on both sides. I think if I try to build it Python first and then present the CLI, I think that it would be lesser experience. So I think that there's always trade-offs.
Cool. Thank you.
Mm-hmm.
Okay, next question behind.
Hi. Will this also replace setup.py?
No, setup.py is a completely different tool for different things. Setup.py is used for libraries, and this is for applications.
Okay, and we'll do one last question. I think that gentleman back there was already there before the bike at the front got filled.
Just to follow up on the source control, checking in your lock files, this has been a big struggle in the Node community. Would you do it for libraries as well as projects? Would you always check in the lock file?
I would not check in the lock file if you are targeting multiple versions of Python where your lock file could be different under the different versions of Python. Hopefully, we've done a lot of work so that it should be a flat lock file that specifies the versions of Python. It really depends on the metadata that is provided by those packages. So if the metadata is good, then you should be able to. But if worst comes to worst, then keep it out.
Okay, with that, let's thank Kenneth. And I'm sure he'd be happy to entertain questions outside of the ballroom.
Yes, absolutely. Thank you very much.